In this section, we are going to look at suspended solids measurements, total suspended solids, and mixed liquor suspended solids for wastewater treatment process management, how to do them, what we are measuring, and what we may use the data for. Suspended solids measurements are valuable across the process as a quick and representative way to assess the technology performance. Looking at the sample marked SDis, a suspended solids measurement on this fully dispersed wastewater sample, will give good representation of the pollution load across all the discernible fractions, shown on the right. The only pollutants not represented in such a measurement are the dissolved biodegradable and inert organic and mineral fractions from the settled sample marked SSET, fractions BO, IO, and IM on the graphic on the right. These fractions are not filterable with the prescribed standard filter used for the analysis. Suspended solids measurements may be taken from several positions on the process, from the PST influent and effluent. Points 1 and 2 on the diagram as a PST performance check, or the PST effluent and the final effluent. Points 2 and 10 on the diagram as a secondary treatment and FST performance check. The mixed liquor suspended solids measurement, taken at point 6 on the diagram, is another vital performance measurement check performed routinely to assess the biomass for various process control settings. Suspended solids checks on settled tank supernatant and on jar tests deliver valuable information about settling efficiency and chemical dosing efficiency. A suspended solids measurement is done by filtering a sample of wastewater containing the filterable constituents of wastewater through an appropriate filter for the application. Filter is weighed before, slide 2, after drying and acclimatizing the filter in a desiccator. The sample size is selected based on the solids load in the sample, slide 3. The sample is filtered with the available filtering apparatus and placed in the 105 degrees centigrade, preheated oven for 2 hours, slide 4 and 5. When all the water has been evaporated from the solids residue and filter, the dried filter is weighed again to record the dry solids filterable mass, slide 7. The difference in recorded mass for the filter measurements is the dry solids for the volume of sample used, which must be converted to a milligram per liter value, with the calculations shown slide 8 and 9. Suspended solids value of a sample of mixed liquor is measured in exactly the same way as shown before, with the customary change of using a smaller sample size due to the high solids in the sample. The MLSS value is crucial to keep track of the accumulated solids of the biomass culture suspended in the bioreactor. The mixed liquor in the reactor is a mixture of bioculture floc, complexed and infused by the mass of pollutant solids that are continuously mixed into the reactor. The mass transfer of the solids in the mixed-in wastewater to the bioculture floc in the reactor describes the filtering action of the reactor as its method of pollutant removal. A suspended solids analysis may give performance indicators for areas of the process, like the PST, the secondary treatment, and the final effluent quality. Measuring the supernatant of settled samples, such as in the image marked SFST supernatant, gives valuable information about sludge quality or the settling efficiency if the settling was chemically assisted. Suspended solids analysis is also very accurate to assess jar tests when determining the dosing rate and concentration efficiency of coagulants.
This has been a demonstration video of extracted content from introductory training modules for wastewater treatment process and technology, authored by Rolf Skay of RES Enviro.